All right, so today we're going to talk about what are some of the key points when we are looking at quadratics. So oftentimes you're going to get questions that give you the function and ask you these questions right here, these 7. So that's really what we're going to focus on today, and we're going to use Desmos. So the first thing I'm going to do is on my computer up here, I'm going to type in our very first function, and I really only need to type in this part. So I'm going to type in, let's see, show you what I'm doing here. I'm going to type in x squared plus 4x plus 4. All right, and that's going to give me this parabola right here. So then it's asking us to tell whether, first of all, it opens up or down. So do you see how the open part up here is up? So our first answer here, does it open up or down? This one's going to be, it opens up. Next question asks us about the vertex. So the vertex is that point, that minimum or that maximum. So that's what we're looking for next. So we're going to take our graph and we want to find the very point where it turns. In this case, it's a minimum. And so our turning point is going to be at -2, 0. It's always going to be a point. So we're going to come back here, and for our vertex, we're going to put -2, 0. All right, next is asking for the axis of symmetry. So remember, that's the one that goes straight through the middle. All right, so our axis of symmetry is going to go run right on this line right here, which means x is equal to -2. So I'm going to type that in up here. All right, and it drew that straight line right through the middle of my graph. Now I'm going to come over here and make sure that this is turned on. All right, so it is turned on. All right, so really at any point on this line right here, that x is going to be equal to -2. So that's our axis of symmetry. So axis of symmetry, we want to say is x equals -2. It's always going to be this number in your vertex. All right, so our solutions. Solutions are another word for zeros. So we want to look, where does it hit the graph at x equals, or excuse me, at y equals 0. So it's going to be right here. So in this case, this one only has one solution. So our solution is also the same as our vertex. It's the place where it hits the x-axis, or the x-intercept. So our solution here, same as our vertex, -2, 0, and that's the only one that we have. Next, we're going to look at the y-intercept. So we're looking at, where does this cross the y-axis? So it crosses our y-axis right here at 0, 4. So that's our y-intercept here, 0, 4. Next, we're going to talk about domain and range. So if you remember back when we were doing graphs at the very beginning of the year, domain talks about your x-axis. So where does it span across the x-axis? So if we think about this, we're going to say that this continues up forever and ever, and we can zoom out and see that. So I'm hitting the zoom out button here. And as we zoom out, we can see that this keeps going on. If we stretch this out forever, it would go on forever and ever in both directions on the x-axis. So we want to say that our domain is all real numbers, or from -infinity to +infinity. So domain, you can either write this symbol, which means all real numbers, or -infinity, +infinity. It goes on forever and ever in both directions on the x-axis. Now the range, if you look at it, it only goes on forever and ever in this upward direction. So it does have a bottom point. It has that minimum. So we want to say it starts where y equals 0, but it goes on forever and ever into the +infinity. So how we would write that is we would say y is greater than or equal to 0, or from that exact point of 0 to positive infinity. So you could say it either way. All right, so we're going to go ahead and do our next function here. So I'm going to erase all of this stuff. And I'm going to type in my next function, which is x squared minus 8x plus 12. So there's that one. And that's the graph that they gave us right here. So again, our first question asks us, should we be opening this parabola up or down? So since it has a bottom, it's going to open up like a bowl. So we're going to say for our first question, does it open up or down? It's going to open up again. And if you remember back to the notes that we took a few days ago, whether it opens up or down really depends on this first part right here. So this a value is 1, this a value is 1, and since both of them are positive numbers, it's going to open up. When we get down to this next one, since it's a negative number, it's probably going to open in the opposite direction. All right, so next we're going to look for our vertex. So vertex talks about the minimum or the maximum, that turning point. So that's what we want to look for. So we're going to come down here, and our turning point this time is at 4, -4. So that's our vertex. So our vertex here is 4, -4. All right, now our axis of symmetry, remember, is always going to be the x value there. So the x value is 4, but we'll prove that. And we'll say if our x value is 4, that's going to run all along this line right here. I always like to type it in. X equals 4. And then we can see that it actually does create that mirror image here on both sides. So that's the axis of symmetry. So x equals 4. All right, remember solutions, those are like our zeros, and our zeros happen when it hits the x-axis. So what two numbers does it cross on the x-axis? So if we look here, it looks like it's going to cross 2 and 6. Okay, so we can always kind of hover over and click and make sure it does have 2, 0, and hover over and make sure it says 6, 0. So those are our two solutions here, our two zeros. 2, 0, and 6, 0. Those are our two solutions. All right, our y-intercept, that's going to be where it crosses the y-axis. So we need to kind of zoom out. So we're going to zoom out. And here's our y-intercept, and it looks like it is at 0, 12. Y-intercept would be at 0, 12. All right. Now again, we're going to talk about our domain and our range. So domain talks about where it spans on the x-axis. So if we go back up to our graph, we can see it's going to keep going forever and ever in this direction and in this direction, which means it's going to continue to span outward both left and right, which tells us again that this is all real numbers, or negative infinity to positive infinity. And our range talks about our y values. So where on this graph are our y values going to be included? And so we see that we have a minimum. So the y values cannot go below this number right here. So we can't have a y value of -10, right? But we can have a y value of any other one that's higher or greater than this number right here. So we want to go back and we want to look at what number that is. So that's 4 and -4. That's our vertex. We want to use the y value there, so it's going to be -4. So we want to say our y's are going to have to be greater than -4. So we could write that like y is greater than or equal to, because it could be that point. We did say that was a point on our graph, -4. Or, remember this hard stop, -4, and then goes on to infinity in the positive direction. But we can't have a hard stop there because infinity is just some number that goes on forever and ever. It never stops. All right, so we're going to look at one that's a little bit different now. So we're going to go ahead and type this one in. So I'm going to clear this stuff out. And I'm going to type in -2x squared plus 4x minus 2. All right, and we're going to look at that parabola. All right, so this one is a little bit different. This one is going downward. I'm going to zoom in a little bit because we don't need all this extra graph. There we go. And we can move that graph up. All right, so the first thing we're looking at is, does it open up or down? So if you look at it, this time it is in the opposite shape. So it has a maximum number, which means the arrows point down. So we're opening it down. So that's our first thing, open down. Next up is the vertex. So we're looking for that turning point. So our turning point in this case, we're going to hover over. And it looks like our turning point is at 1, 0. That's our vertex. So vertex should be at 1, 0. All right, the axis of symmetry, remember it's always going to be this x value, but we'll type it in just to make sure. So we're going to say x equals, and we'll type it in up here, see if it does equal 1. And then check your graph and make sure that does give you that line of symmetry there, and it does. So x equals 1 is our axis of symmetry. Our solution, so remember that's where it crosses the x-axis. And in this case, it only crosses the x-axis one time, and it crosses on that vertex. So we only have one solution here, and that is going to be the same as our vertex. It's going to be 1, 0. Y-intercept, so we're looking where does it cross the y-axis. It looks like it crosses at 0, -2, so let's hover over and click and make sure. And it does cross at 0, -2, that's going to be our y-intercept. Okay, and then our domain and range. So our domain, we're still stretching out in both directions, left and right, forever. So all real numbers. Or -infinity to +infinity. And then our range value, so this time we have a maximum. So that means it cannot go higher than this number right here. It has to go lower. And when we talk about range, we're looking at that y value, which is our 0. So we have to say that all of our numbers are less than 0 on the y-axis. Okay, now it could equal 0 because 1, 0 is our turning point, so that's still a point. So we're going to call this y is less than or equal to 0, or we can include 0, but we're going to -infinity. Now, when you write this, technically you're supposed to write this in order from least to greatest. So instead of writing from 0 and down, we're actually going to change it, and we're going to write from -infinity to 0, because we always wanted to go in order from least to greatest. So even though I would accept this, this is the proper way to write it. So we're going to kind of say this one's wrong, this one is the right way. All right, so a couple other things that I want you to notice. If you look very carefully, we talked about how this very first value, this a value, determines whether it curves up or down if it's negative. Okay. The other important thing to notice too is that this last value here, your c value, is your constant. That is going to be your y-intercept. So we have 4, and our y-intercept was 0, 4. Here we have +12, and our y-intercept was 0, 12. Here we have -2, and our y-intercept was at -2. So we can always kind of pick out certain points of the graph just by looking at our original function.